Yeah, hello dear students. You are welcome to session 4 of Core Mathematics for Senior High School. So under this session we'll be treating the topic Algebraic Expression. Algebraic Expression. So let's look at the outline. So by the end of this lesson you should be able to distinguish between like and unlike terms, perform basic operations on algebraic expressions, multiply two binomial expressions, understand the concept of difference of two squares, factorize algebraic expressions, factorize algebraic trinomials, express statements and phrases in mathematical terms, simplify algebraic fractions, and determine the condition under which an algebraic fraction is undefined. Right, so these are the areas that we'll be touching in this lesson. Okay, so shall we set off now? Okay, so what is an algebraic expression? Algebraic expression is basically a mathematical expression made up of a combination of numbers, letters, and then the basic operations. Right, so the addition, the subtraction, the division, and multiplication. Right, so this a typical example of an algebraic expression here. Right, so 5a minus 3b plus 7 plus 6b minus 2a. Right, so like we said, it is a combination of numbers. So we are seeing 5, and letters. You are seeing a, you are seeing b, you are seeing another a here, as well as operations. So you are seeing the minus, you are seeing the plus. And there is also multiplication, right? Because 5a means 5 times a, right? 3b means 3 times b, right? So that is what an algebraic expression simply is, right? And then we call the numbers standing on their own as constant, right? So here we are seeing only 7 standing on its own, right? So this 7 is known as the constant, right? So that is the general concept of algebraic expression. Right, and we have what we call the terms of an algebraic expression. Right, so the term simply refers to the individual unit of an algebraic expression. Right, and basically it is the addition and subtraction that separate terms. Right, so here if we are to list the terms are simply 5a, negative 3b, 7, 6b, and then negative 2a. Right, so what is separating the terms are the addition and the subtraction. Right, so in between 5a and 3b the operation is what is minus, and because there's an operation, because the minus operation is separating the 5a from the 3b, this 5a becomes a separate term from the 3b. Right, this 7 also becomes a separate term from the 3b here and the 6b. Right, so in all there are 1, 2, 3, 4, 5 terms in this algebraic expression. Right, so we have two kinds of terms. We have the like terms and the unlike terms. Right, so like terms are those terms with the same variables and raised to the same power. Right, so from this example here we can say 5a and negative 2a are like terms because they have the same variables of a. Similarly, negative 3b and 6b are what? Are like terms because they have the same variables b, and they are raised to the same power of what? Of 1. So bear in mind 2y and y squared are not like terms because they have different powers. We said like terms, they have the same variables. That is the first condition. The second condition is that they are raised to the same power. So 2y and y squared, though they have the same variable of y, they have different powers, so that disqualifies them from being like terms. Right, so let's now look at unlike terms. So that is the opposite of like terms. So these are terms with different variables or with same variables but with different powers. Right, so from this same example, 5a and 6b are unlike terms because they have different variables. Also 2y and y squared are unlike terms because they have different powers. Right, so that is the general overview of algebraic expression. Right. Okay, so now let's look at the operations on algebraic expression. Right, so we'll start with the addition and subtraction of algebraic expression. So basically we can only add and subtract like terms, right? In any algebraic expression we can only add or subtract like terms, right? So if we are given this expression 5a plus 7b minus a plus 3b, right, the first thing we have to do is to group like terms, right? Is to group like terms so that we can now add or subtract them, right? So we are going to have 5a minus a plus 7b plus 3b. So in grouping the like terms, make sure that you carry each term should go along with the operation that is in front of it, right? So if we are to put 5a and a together, since they are like terms, in grouping them we are going to consider the operation sign in front of this a. That's why here it is 5a minus a, right? So take note of that. In grouping the like terms, the operations must go along with the terms must go along with the operation that was in front of them initially, right? So 5a minus a plus 7b plus 3b. Now you can solve, right, because you've grouped the like terms. So in solving, you're just going to consider the coefficient, right? So we just add or subtract the coefficient of the like terms, and then we maintain the same variable. So what is 5a minus a? It is simply the coefficient of this first term here, which is 5, right? So what is 5 minus? Now whenever you have a variable standing on its own without any number written in front, the coefficient is 1, right? But then we don't bring it because it is insignificant, right? So but then when you see any letter or any variable standing on its own, the assumed coefficient is 1, right? So 5a minus a is more of 5a minus 1a, right? So what is 5 minus 1? Right, so 5 minus 1, the answer is 4. So 5a minus a is 4a, right? What is 7b plus 3b? So the result is simply the 7 plus the 3, which is what? Is 10. So 7b plus 3b is 10b. So that is how we add or subtract like terms or an algebraic expression, right? So let's take a look at this example too. So we have 2m plus 4 minus 9m squared plus 3m plus 11m squared minus 7. So the first thing is to what? Is to group like terms, right? So 2m plus 3m, they are like. Minus m squared plus 11m squared, they are also like terms. Plus 4 minus 7, they are also like terms, right? So what is 2m plus 3m? It is 5m. What is negative m squared plus 11m squared? The answer is 2m squared, so plus 2m squared. And what is 4 minus 7? The answer is minus 3. So that is as simple as that, right? Now take note of this point here. In writing algebraic expressions, we always order the terms in alphabetical order, right? So we group them in alphabetical order, and the constant is always the last term, right? So in this example, you are seeing that the 3 came last, right? So the constant must always be the last term. Now assuming we had m and n, right, the m would have come first before the n. Alright, so here you see the a came before the b, right? So 4a plus 10b. So make sure you always arrange or list them in alphabetical order, and always the constant or the number standing on its own should be the last term. Right, so that is the most appropriate way of presenting an algebraic expression, right? Okay, so let's move on. Okay, so let's now look at multiplication and division of algebraic expressions. So under multiplication, we simply multiply the numbers and then we multiply the variables. That's all. Right, so what is 5a times 3b? So we are just going to multiply the numbers, right? So what is 5 by 3? It is 15, right? And then you multiply the variable. So what is a by a times b? It is ab. So the answer for 5a times 3b is what? Is 15ab. As simple as that. So here too, 2y times 7y. So the numbers will multiply themselves, and then the variables also multiply themselves. So what is 2 times 7? It is 14, right? And what is y times y? Y times y is y squared. So the answer is 14y squared, right? So we have another example here. 5pq squared times 4p cube q cube. So numbers multiply numbers, variables multiply variables, right? So what is 5 times 4? It is 20, right? Now what is p times p cube? So you are going to multiply the variables with the same letters, right? So here p, so for this first expression there is p here. For this second expression it is p cube. So since they have the same pp, we are going to multiply them, right? So what is p times p cube? Right, so we can apply our knowledge on indices here. So p times p cube, and the indices, because they are multiplying, they have the same base of p. You are going to just add their exponents, right? So it's going to be p to the power 1 plus 3, and that gives us p to the power 4, right? For the q2, here was q squared, here was q cube. So if they are multiplying, you're going to get q to the power 2 plus 3, and that gives us q to the power 5. Right, so the final answer becomes 20. So the 20 was gotten from the 5 by the 4, 20, and the p to the power 4 was gotten from p times p cube, right? And then the q to the power 5 was gotten from q squared times q cube, right? So that is how to multiply algebraic expressions. Let's now look at a division. So under division too is the same ideology, right? Numbers divide numbers, variables divide variables, right? So what is 8a cubed b squared divided by 2ab? So for each item here, right, you are going to pick it, you are going to divide it by its corresponding partner here, right? So 8 is a number, so you are going to divide 8 by the corresponding number here, which is 2. So what is 8 divided by 2? It is 4, right? So you have 4 here. We pick a cube, right? Now what is a cube divided by a? So you are going to also divide this a by its partner here. So since it's a cube, you are going to divide it by a. So what is a cube divided by a? So here too we can apply the law of indices, that when two numbers are divided with the same base, you just subtract their exponents. So a to the power 3 divided by a to the power 1. A letter stand on its own has a power of 1, right? So a to the power 3 divided by a is simply going to be a to the power 3 minus 1, and that is a to the power 2. And then we come to the b aspect. So b squared divided by b. So here too is going to be b to the power 2 minus 1, and that is what? That is still b. So the answer for 8a cubed b squared divided by 2ab is 4a squared b. So basically numbers will divide numbers, and then each variable will divide its corresponding variable. I believe it's clear, right? Okay, let's proceed. Okay, let's now talk of the expansion of algebraic expressions, right? So there are times that you would have a term outside, and then it is multiplying another set of terms within a bracket, right? So here we have 3y is multiplying the expression x plus y. So here you are seeing that within the bracket we are having two terms, that is x and y, right? We are having two different terms, x and y. So how do you expand this algebraic expression? So what you are going to do is that you are going to pick each we are going to multiply the term outside by each of the terms inside the bracket. So you are going to pick 3y and multiply by x, and also multiply by y, right? And then you maintain the same operation within the bracket. So what is 3y times x? It is 3xy. And then plus, what is 3y times y? It is 3y squared. As simple as that. So that is all that we do under expansion of algebraic expression. You just pick the term outside, and then you multiply by each individual term inside the bracket. Alright, so let's look at this example 2. What is 3 minus 2 into bracket a minus 1? right? So we're going to have 3 minus, what is negative 2 times a? Bear in mind, we have to consider the operation in front. Always consider the operation in front of the number that is multiplying the bracket, right? So what is negative 2 by a? It is negative 2a, right? What about the next one? What is negative 2 times negative 1? Negative times negative is positive, so negative 2 times negative 1 is positive 2, so you're going to get plus 2 here. So you're going to get 3 minus 2a plus 2. So from here we are going to group like terms, right? So you can see that 3 and the 2, since they are numbers, we can put them together. So we have 3 plus 2 minus 2a, giving us 5 minus 2a, right? But you can rewrite this one as negative 2a plus 5. Negative 2a plus 5 is the same thing, right? Okay, let's look at this example 2. We have 2 multiplying the expression 2p plus q plus 3 multiplying the expression p plus 3q, right? So what is 2 times 2p, right? So 2 times 2p, that is 4p. And what is 2 times q? So 2 times q is what is 2q, right? So 2 multiply 2p, it would also multiply q, right? So 3 by p, right, gives us 3p. 3 times 3q, right, gives us 9q, right? So we'll end up getting 4p plus 2q plus 3p plus 9q, right? So from here we group like terms, right? So we group all the p's and then all the q's. So we are going to have 4p plus 3p, right, and then 2q plus 9q. Right, so 4p plus 3p gives us 7p, and then 2q plus 9q gives us 11q. Right, so that is that for expansion of algebraic expression. Okay, let's now look at the multiplication of 2 binomials. Now, when we talk of a binomial, it is just an algebraic expression which is made up of 2 different terms, right? So we have examples here, 2x plus y. Now this is a binomial. Why? Because it consists of 2 different terms. So 2x is one term, y is another term, right? P minus 3, p is one term, 3 here or negative 3 is another term. A squared is one term, b is another term. So a squared plus b becomes a binomial, right? So let us now look at how we can multiply 2 binomials, right? So assuming we are to expand the expression c minus 1 in one bracket, multiplying the expression d minus 4, right? So this is one binomial multiplying another binomial. So what you are going to do is that you are going to pick the first term in the first bracket, right, and then you multiply by the second bracket. Afterwards, you pick the second term in the first bracket, and then multiply by the same second bracket, right? So in effect, you are going to have c multiplying the expression d minus 4, right, into this bracket, and then the minus 1, which is the second term, multiplying the same expression d minus 4. Right, so from here you simply apply your knowledge on expansion. So the term outside will multiply each of the terms inside. So c times d becomes cd. C minus 4 gives us minus 4c. Minus 1 times d gives us minus d. Minus 1 times minus 4 gives us positive 4. Right, so from here just group like terms and solve. Right, so if there are like terms, you group it and you solve. Now here there are no like terms, right, because you have cd minus 4c minus d plus 4, right? So there is no like term, right? So since there is no like term, we leave it the same as it is. Okay, so let's move on. Okay, let's now look at squares of binomials. We are still on the multiplication of 2 binomials, right? But what if we get the same binomial multiplying itself, right? So what if we have a plus b, right, multiplying itself, so multiplying a plus b, right? So it means we can express this one as a plus b all squared, right? That is why we say the squares of binomials. right? So a plus b is a binomial which has been squared. So how do you go about this, right? So if we are to use the basic method or the general method, you first of all expand it, and then you get a plus b in one bracket multiplying the expression a plus b, and then the term, this first term here, a, will multiply this entire bracket, and then this second term b will multiply this same bracket here. So you're going to get a into bracket a plus b plus b into bracket a plus b, right? Then the term outside is going to multiply each of the terms inside the bracket. So what is a times a? It is a squared. What is a times b? It is ab. What is b times a? It is ab. What is b times b? It is b squared, right? So we have a squared plus ab plus b squared. So if you check, you realize that ab and ab, they are like terms, so we can add, right? So we are going to have a squared plus 2ab, right? Because the coefficient of this ab is 1, that of this ab is also 1, so 1 plus 1 gives us 2. So the result of ab plus ab is 2ab, right? So our final answer becomes a squared plus 2ab plus b squared, right? Now let me show you a straightforward method of finding the squares of binomials, or the results of the squares of binomials. So assuming I have a plus b all squared, right? And this is a straightforward approach that can help you, especially in your objectives, right? Yeah. So how do you solve this in a straightforward manner, right? So this is what you do: square the first term. Right? So what's the first term here? It is a. So what is a squared, or what is the square of a? It is a squared, right? So write the a squared. Multiply the two terms in the bracket and multiply everything by 2. So what is a times b? ab. What is ab times 2? 2ab. So plus 2ab, right? And then you square the second term, which is b. So what is b squared, or what is b which has been squared? It is b squared, right? So the final answer is a squared plus 2ab plus b squared. Once again, you square the first term, a squared, then you add it to the product of the two terms in the bracket, a times b times 2, so plus 2ab, and then you add it to the square of the last or the second term in the bracket, so plus b squared. As simple as that, right? And that is when the operation separating the two terms is addition, right? Now let's come to the second example. So what if it is subtraction? So a minus b all squared. So let's look at the basic or the standard approach. So it's going to be a minus b in one bracket multiplying the expression a minus b in another bracket. So this a will multiply this bracket, so you're going to have a into bracket a minus b, and then this minus b will multiply the second bracket, so minus b into bracket a minus b. So what is a times a squared. What is a times negative b? Negative ab. What is negative b times a? It is negative ab, right? And then what is negative b times negative b? It is positive b squared. So now minus ab and minus ab, they are like terms, so we can solve, right? So what is negative 1 minus 1? It is negative 2, right? So the result of minus ab minus ab is negative 2ab, right? So our final answer for this particular expression becomes a squared minus 2ab plus b squared, right? Good. Here too, if you want to use the straightforward approach, you square the first term a, right? So you square it, so you're gonna get a squared. You multiply the two terms. So what is a times negative b? Negative 2ab times, a times negative b is negative ab, times 2 is what? Negative 2ab, as you are seeing here, and then you add it to the square of the second term. What is negative b all squared? It is positive b squared, right? So that's just a shortcut approach of solving squares of binomials, right? So let's look at this question. We have to simplify 2x plus 3 all squared. Right, so in fact, when you're asked to solve questions like this in let me say the subjectives or the theory aspect, you don't use the shortcut method. Okay, so you're going to use the standard approach. So you're going to expand this one as 2x plus 3 in one bracket, multiplying the expression 2x plus 3 in another bracket, and then you pick the first term, you multiply by the second bracket. So you're going to get 2x multiplying the expression 2x plus 3 plus 3 multiplying the expression 2x plus 3. What is 2x times 2x? It is 4x squared. Plus, what is 2x times 3? It is 6x. What is 3 times 2x? 6x. What is 3 by 3? It is 9. Right? So we are having 4x squared plus 6x plus 6x plus 9. Obviously we can solve these two, right? So 6x plus 6x gives us 12x. So our final answer becomes 4x squared plus 12x plus 9. I believe you get it. Okay, let's move on. Let's now look at an interesting concept known as the difference of two squares. Right, so as the name suggests, we are finding the difference of two numbers that have been squared. So we have a squared minus b squared. So how do you go about it? So the standard formula or the rule for dealing with such a scenario or such a situation is for you to add the two numbers apart from the squares, put them in one bracket, open another bracket, and then subtract the two numbers. That is all. So a squared minus b squared is equal to a plus b in one bracket multiplying the expression a minus b. Right, so it's just the sum of the two individual numbers apart from the squares. Okay, so here the numbers are a and b, right, but then they've been squared. So the result is going to be the sum of the individual numbers multiplying the difference of the individual numbers. So a plus b in one bracket multiplying a minus b in another bracket. Right, so let's look at this question. We have to simplify 4x squared minus y squared. Good. So it means that the first thing you have to do is establish the number that is being squared. You get me? You see here you are seeing 4x squared. Now 4 is a perfect square, or 4 is a square of 2. So the first thing to do is to break down this 4 into 2 squared. Right, so you're going to have 2 squared x squared minus y squared, and then you're going to factorize this one and get 2x all squared, because in difference of two squares we need the number that is being squared. We don't need the result of the square of the number, we need the number that is being squared. So we have to see the power 2. You get me? Here it was 4, but then we don't need 4 because 4, it means that you have gotten the result. We need to see the square. That is why here we split it into 2 squared. So 2 squared x squared. Then we factorize this one, right? So we group them as one. So 2 squared x squared is the same as 2x all squared. So this becomes one term or one unit. This becomes 1 unit. So we have 2x all squared minus y all squared. So now we can apply the difference of two squares here. So it is going to be the sum of 2x and then y multiplying the difference of 2x and y. So that gives us 2x plus y in one bracket multiplying the expression to x minus y. I believe you get it right. Let's look at this question too. We have to simplify 12a squared minus 27b squared. Right, so it means always whenever you are given a number, then it means that there is a perfect square component in that number. So you have to find that number that was squared in order to arrive at that perfect square. Again, here the number was 4, but then we don't need the 4. We need the number that was squared to get the 4. Right, so here too we are getting 12a squared minus 27b squared. Right, so here we can factorize. Okay, we can factorize. So 3 can divide 12, we can divide 27, right? So let 3 come out, and then 3 goes into 12 4 times, right? So you're gonna get 4a squared, right? Minus 3 into 27 is 9 times, so minus 9b squared. Now when you look at this bracket, it is a classic picture of difference of two squares. 4a squared minus 9b squared. This 4 is a perfect square. This 9 is also a perfect square. But then we don't need the 4, we don't need the 9. We need the numbers that was squared to get the 4 and to get the 9. So for 4 it was 2, right? So we are simply going to write that as 2a all squared. Because when you expand 2a all squared, you are going to arrive at 4a squared. Here to 3. So here it was 9b squared. 9 is a perfect square of what number? Of 3. So it's simply going to be minus 3b all squared. Then we can apply the principle of the difference of two squares here. So now we have 2a and then 3b as our individual units. So 2a is one square, 3b is another square. So we can now find the difference of these two squares, right? So it's simply going to be 2a plus 3b in one bracket, multiplying the expression 2a minus 3b, and then you bring the 3 outside, right? So that is how to approach this particular question. Right. So just have this formula in mind, right? The difference of two squares, the result is what? The sum of the individual numbers multiplying the difference of the individual numbers. I believe it's simple, right?